In this video we are solving trig equations, and the emphasis in this video is that we can sometimes use the quadratic formula to solve a trig function. Sometimes you just can't factor, and when you can't factor, using the quadratic formula might be a great idea. So let's take a look at this problem. It says, find to the nearest degree the values of theta in the interval 0 is less than or equal to theta is less than 360, such that 2 times cosine squared theta minus 4 cosine theta plus 1 is equal to 0. I'm going to bring this, we don't need to, this cannot be factored. And so the surest way to try to find solutions here is I'm going to go ahead and do a u substitution right away. So I'm going to say u is equal to the cosine of theta. And let's rewrite this trig equation in terms of u. So that gives us 2u squared minus 4u plus 1 is equal to 0. Now let's use the quadratic formula here, right? You should have the quadratic formula memorized. For the benefit of the viewer, we have x is equal to negative b plus or minus the square root of b squared minus 4ac, and then the whole thing divided by 2a. What is the value of the a here? Well, the value of the a there is a 2. What is the value of the b here? The value of the b is a negative 4. And the value of the c? The value of the c is a 1. Let's plug it in and use this to solve for u. So u is equal to a negative of this negative 4 plus or minus the square root of this negative 4 squared minus 4 times this 2, and then the c, which is a 1, and this whole thing divided by 2 times this 2. So we just need to sort of simplify and clean things up. So u is equal to a negative of a negative 4 is a 4, plus or minus the square root of negative 4 squared is 16, minus 4 times 2 is 8, so we have this. This whole thing is divided by a 4. So this becomes u is equal to 4 plus or minus the square root of 16 minus 8 is 8, so there's that, and we divide this by 4. We're getting very close to having solutions for u. So u is equal to 4. I'm going to split this into 2 now. So this is 4 over 4 plus or minus radical 8 over 4. Concentrate a little bit on this radical 8 over on the side. Radical 8 is the same thing as 2 times 4. 8 is the same thing as 2 times 4, and 4 is 2 times 2. So this is radical 2 times 2 times 2. We have a pair of 2, so we can pull one out, so this becomes 2 radical 2. So this can be rewritten. U is equal to, 4 over 4 is 1, plus or minus 2 radical 2 over 4. This 2 over 4 is the same thing as 1/2, and so this is really u is equal to 1 plus or minus radical 2 over 2. And there is 2 different solutions here. Keep that in mind. One of them looks like this. U is equal to 1 plus radical 2 over 2. And the other one is that u is equal to u minus radical 2 over 2. What are we going to do with these? Well, we can't do very much with them as they are. We need to be able to take we're going to eventually bring back some values. We're going to change these into decimals now. I'm going to go ahead and change these into decimals. So this is approximately. Feel free to use a lot of decimals. You can't go wrong by putting lots of decimals here. So I'm going to type in 1 plus. Notice how I use parentheses here to avoid making a mistake with order of operations. I'm putting in 1 plus, put parentheses, square root of 2. Make sure you're out of the parentheses then. Yep, gotta close those ones. So this is just the square root of 2 divided by 2. And then I close the parentheses there. And that comes out to be 1.707106781. So I'm going to say this is approximately 1.7 0, 7, 1, 1, rounded to the nearest tens, hundreds, thousands, 10,000s, and 100,000s. I went all the way out to the thousands place. And over here, U is approximately, you have to type this part in, so that's going to give us, let's see, that's going to give us 1 minus radical 2 over 2. That looks like this. 1 minus, use parentheses, radical 2. Going to need to close that parentheses on that one. Over 2, and then close this parentheses. See how I've avoided, there's that parentheses and that parentheses. That's to avoid having strange things happen with order of operations. This gives us 0.2928932. I'll take it all to at least to the 2, since I don't have to round up. So this is that U is approximately 0.2928932. So we have two possible values here. It's time now to go ahead and bring back what that U was filling in for. What was that U filling in for? Well, that U, if you go way back here, we said the U was the cosine of theta. So we're going to bring these values back. See, U is equal to this, which means that the cosine of theta is equal to 1.70711, right? Or U is equal to, or we have that the cosine of theta is equal to this value for you over here, which was 0.2928932. So we'll put down 0.2928932. Well, take a close look at this one first. This is saying that the cosine of theta is equal to something bigger than 1. That's not possible. That saves us time because we can't find any theta that'll make that happen. For this one, the only way to do it is by using the calculator and taking the inverse cosine of both sides. So we do that now. Not the inverse cosine, sorry. The inverse cosine of the cosine of theta is equal to the inverse cosine of 0.2928932. Let's use the calculator. The calculator here, it's on degrees, and so we can type this in. Putting in the inverse cosine of that number, we end up with the inverse cosine of 0.2928932. The calculator says that's 72.9 degrees. 968. Now, this problem said that we can give this answer to the nearest whole degree, and so now is the time when it's safe to round. So we have 72.9 to the nearest whole degree becomes 73, and so one possibility, one answer is that theta is equal to 73 degrees. That's not the only one though. What do we have to do next? It's very good if you said that we have to reflect. We have to reflect across the x-axis because it's a cosine. So 73 is about there. That's 73. Reflect across the x-axis, right? That takes us right there. If this is 73, that means this is 73. So to find this larger angle, let's go 360, but then back up 73. So it's 360 minus 73, which gives us 360 minus 73 is 287. And so these two angles are 73 degrees and 287 degrees. And these are the final answers.